Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a continuation of a lecture video on chapter 4 which is Induction Motto. Okay, so my name is Dr. Nawazullah binti Muhammad. Here is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Okay. So basically this is the list of contents that we are going to cover in chapter 4. However, in this video we are going to cover only on the subtopics on sleep and sleep speed. Okay, so let's move to the topics of this video, which is sleep and sleep speed. So basically what is the main difference between the sleep and also the sleep speed? Okay, so for the sleep speed, or we can also call it as a sleep RPM, usually we write in terms of the symbol of and sleep. So the sleep speed is defined as the difference between the synchronous speed versus the rotor speed. So the equation of the sleep speed is given by n sleep is equal to ns minus nr. Okay, ns is the synchronous speed minus the rotor speed. Alright, and then for the sleep, okay, the definition of the sleep is a ratio of the speed difference, okay, this difference over the synchronous speed. Okay, the equation of the sleep is given by S is equal to ns minus nr. Okay, so the speed difference over the synchronous speed, which is ns. Okay, so basically the units of the ns and also nr is given in terms of the RPM, which is a rotation per minutes. Alright. In most of the cases, the motor sleep range between 0 and 1. Okay, so the S value usually will be between 0 and 1. Okay, if the rotor at standstill, meaning that the rotor is locked, the rotor is not moving, the sleep is unity. So meaning that S is equal to 1. Okay, for rotor spinning at the synchronous speed, meaning that when your NR is equal to NS, okay, so the sleep is 0. Okay, next let's have a look at the following example on how to do some calculation on the sleep and also the sleep speed. Okay, so the question here, you have a 0.5 horsepower 6-pole induction motor is excited by the 3-phase 60 Hz source. Okay, if the full load speed is 1140 RPM, calculate the sleep. Okay, so here you see the question gives you the value of the NR. So this is the rotor speed, 1140 RPM. Okay, next you need to calculate the sleep. Okay, alright. So the solution here is, before you can calculate the sleep, you need to calculate the value of the synchronous speed first. So the formula for the synchronous speed, which is ns, is equal to 120 multiplied with the frequency divided by the pole. So frequency in this case is the 60 Hz, okay, and then pole is given by 6 pole. So 120 multiplied with 60 divided by 6, so equal to 1200 RPM. So this is the value of ns. Okay, so once you find the value of synchronous speed, then only you can calculate the sleep. Okay, so the formula of the sleep is equal to ns minus nr divided by ns. Okay, so in this case ns is 1200. Okay, and then NR is given from the question is 1140. So divide by the synchronous speed. So finally the S will be equal to 0.05. Okay. Okay. So next, the voltage and the frequency induced in the rotor are actually depends on the value of the sleep. Okay, so meaning that the sleep will be determined what is the value of the voltage of the rotor and also the frequency of the rotor. Okay, so where you have a formula of the frequency of the rotor will be equal to the sleep multiplied with the frequency of the power source. Okay, and then the voltage induced in the rotor at the sleep S will be equal to the S multiplied with the EOC, which is the open circuit voltage induced in the rotor when at rest. Okay, so let's have a look at the next example on how to use these two formulas. Okay, alright. So example 4.2, you have a 1/2 horsepower 6-pole 3-phase induction motor is connected to a 60 Hz power supply. Okay, and then next we need to calculate the frequency of the rotor. Okay, we need to find the F rotor under the following conditions. So basically we have 4 different conditions. Okay, condition number 1 at standstill. Okay, so in this case rotor is not moving. Okay, so meaning that the S is equal to 1. Okay, for condition number B, at a shaft speed of 500 rpm, so in this case the NR is 500, rotate in the same direction as per synchronous speed. Okay, and then for C, at a shaft speed of 500 rpm as well, but rotating in the opposite direction of the revolving field. Okay, meaning that the direction of the NS is not equal to the NR. Okay, condition number D, at a shaft speed of 2000 rpm, rotating in the same direction as the revolving field. Okay, so the solution for the question is for A. You need to calculate the frequency of the rotor at standstill. So in this case, when it stands still, meaning that S is equal to 1, okay, so the formula of the F rotor is given by S multiplied with the frequency of the power supply, which is 60 Hz. So 1 multiplied with 60 is 60 Hz. Okay, and then next for B, you need to calculate the frequency of the rotor when your NR is 500, rotating in the same direction as the revolving field. Okay, when it has the same direction as per revolving field, meaning that the direction of the NR is equal to the direction of the NS, so the motor speed we consider as a positive value. Okay, so in this case you need to find the value of NS first. So NS is given by 120 multiplied with F divided by pole. Okay, 120 multiplied with 60 divided by 6. So NS is equal to 1200 rpm. Okay, and then now your S is equal to NS minus the NR. So 1200 minus 500 divided by 1200 is equal to 0.583. So this is the value of S. Okay, and then after that you need to calculate the frequency of the rotor. So frequency of rotor will be equal to S slip multiplied with the frequency of the power source. Okay, so S in this case is 0.583 multiplied with the 60 Hz. So now your frequency of the rotor is given by 35 Hz. Okay, alright. For C, you need to calculate the frequency of the rotor at the same speed of the NR, but it rotates in the opposite direction. Okay, when it says rotate in the opposite direction, meaning that the motor speed now is a negative, NR is negative. Okay, so in this case your new S will be equal to NS. Okay, NS is 1200 minus 500. Okay, because the motor speed now is negative. Okay, divide by 1200. So now your S is given by 1.4167. And then next, for the frequency of the rotor is given by S multiplied with F. So your new S will be 1.4167 multiplied with 60. So your frequency of the rotor now is 85 Hz. Okay, so please take note here, when you have the value of S is larger than 1, so in this case meaning that the motor is operating as a brake. Okay, and then finally for the fourth condition, you need to calculate the frequency of the rotor at 2000 rpm, rotating in the same direction as the revolving field. Okay, so in this case the motor speed is positive lah. Alright. Okay, so your new S will be equal to 1200 minus 2000. Okay, and then now you are getting the value of S is negative 0.667. Okay, so the new F rotor, the new frequency of the rotor will be given by negative 0.667 multiplied with 60, you get negative 40 Hz. Okay, so in this case you see the value of S is less than 1, is a negative value, so meaning that the motor is operating as a generator. Okay, alright, so just take note here, a negative frequency means that the phase sequence of the voltage induced in the rotor winding is reversed. Okay, so we can just simply say the frequency is actually 40 Hz. Alright. Okay, so that's all on the topics on slip and also slip speed. Okay, thank you for your time. Thank you for watching my video. I'll see you in my next video. Okay, bye.